The topic of my math video today is radians in the unit circle.
In the unit circle, there are radians that correlate to different degrees. The unit circle is labeled in a counterclockwise layout.
At 0 degrees, we have 0 pi, and at 90 degrees, we have pi over 2, and at 180 degrees, we have pi, and at 270 degrees, we have 3 pi halves. It's important to note that there are many other measurements of radians that are inside this circle. When doing problems with radians, you need to make sure your calculator is in radians, and it should say up in this top right-hand corner if you have a TI Inspire. It's also easy to go back and forth between degrees and radians using this equation right here. This explains that if you want to go from degrees to radians, you have to multiply the degrees by pi over 180.
If you want to get from radians to degrees, you have to multiply by 180 over pi.
For example, if you wanted to convert 120 degrees to radians, you would just multiply 120 by pi over 80. This would give you 2 pi over 3.
Something that also falls under this topic is the elements of the circle. These are things like the tangent, arc, center, radius, sector, and chords. Specifically in this unit are the length of an arc or the area of a sector that the arc creates.
These are the equations to do so. What it is the length of the arc is equal to the angle it creates times the radius. This symbol theta represents the angle. Now to find the area of a sector, it's equal to 1/2 theta times r squared. To practice using these equations, try to answer this question. Find the area and length of an arc with a radius of 9 centimeters and an angle of 7 pi over 4. To find length, we do 9 times 7 pi over 4, which is equal to 49.5 centimeters. And to find the area, we do 1/2 times 7 pi over 4 times 9 squared, which is equal to 223 centimeters squared.
Now we're going to move back to the unit circle. So the unit circle is special because it has a radius of 1 that goes all the way around. Because of this, if we put a triangle in the middle of the circle, it would have a hypotenuse of 1. Because we know this, we can use the Pythagorean theorem to say x squared plus y squared is equal to 1, as shown by this equation. For any point on the unit circle, we can label it xy. This is because it goes x amount of numbers this way and y amount of numbers up. This can also be written as, not sine over cosine, but cosine, comma, sine. We'll use cosine, comma, sine more in the trigonometric identities.
Because x comma y can also be written as cosine comma sine, using this equation, we can also rewrite it using these symbols instead and make cosine squared theta plus sine squared theta equal to 1. Another important equation to remember with the unit circle is when you're solving for tangent, which is sine over cosine.
The unit circle has many applications, but first you have to understand trigonometric ratios.
For trigonometric ratios, you need to know where sine, cosine, and tangent are positive or negative in each quadrant. This will help you when you're solving for how to apply the unit circle when solving for cosine and tangent in future equations.
A saying to help you remember where sine, cosine, and tangent are positive and negative in the quadrants is the saying, all silly turtles crawl. The first word in the saying represents the first quadrant, which is the word all. This means that all of them are positive, sine, cosine, and tangent. Because the next word in the saying starts with an S, this means that the sine is positive and the cosine is negative. The next word turtle starts with T, which means tangent is positive. Because tangent is positive, we can look at this equation, which is sine divided by cosine. This means negative divided by a negative is equal to a positive, meaning that both sine and cosine are negative. But I accidentally wrote positive because the wind was blowing and I was distracted. The last word crawl starts with a C, meaning that cosine is positive and sine is negative.
It's important to understand this concept because when we move into the applications of the unit circle, it will give you questions to find sine or cosine, and it will give you something like this where it says theta is in between 0 and 3 pi fourths, and you'll need to figure out what quadrant that is and if sine or cosine is positive in that space.
Going back to this unit circle where we labeled the radian measurements, we know that the radian measurements correspond with other degrees. We can go in between the degrees and radian measurements by using this equation that was shown earlier. The trigonometric ratios also are another element that can be found on the unit circle. They correspond to radians and degrees as well. The trigonometric ratios add an extra layer to this unit circle and represent sine and cosine.
The trigonometric ratios show the values of sine and cosine at each point. I'm now going to fill in the trigonometric ratios. Okay, it got a little bit confusing, so I put the trigonometric ratios in green and the radian measurements in pink. So as we can see, going around the circle, we have these elements right here.
Because the coordinates are written like this, we can see that in quadrant 1, both of them are positive. In quadrant 2, only sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. This is because all silly turtles crawl. Once again, there are more trigonometric ratios that are inside the circles besides the ones that are just shown on here. We can memorize this whole entire thing, or we can do something called the hand trick that you guys might remember. The hand trick is a convenient way to avoid having to memorize the whole entire unit circle. You start by, in the palm of your hand, having x, the square root of x over 2. Then on each finger, you have 0, 30, 45, 60, and 90 degrees.
When wanting to find a line's trigonometric ratio, you can look at the line and see what degree it's at. You put that finger down, such as if it was 60 degrees, and see if you're trying to find sine or cosine. If you're trying to find sine, you count how many fingers are going this way, and you put that in the place of x. If you're trying to find cosine, you count how many fingers are going this way and put that in the place of x.
So if you were trying to find sine of 60 degrees, you'd count 1, 2, 3, and then it'd be the square root of 3 over 2. Try to apply this hand trick by finding sine at 90 degrees and cosine at 3 pi over 4. Pause the video and then resume for the answers. Here are the answers.
In finding sine of 90 degrees, you put the 90 degree finger down and count 1, 2, 3, 4.
This becomes the square root of 4 over 2, which is equal to 2 over 2, which is equal to 1.
When finding the cosine of 3 pi over 4, that's in radians, so you have to figure out what angle it's at that point. So if we go back to the unit circle, we can see that 3 pi over 4 is equal to 45 degrees. So we put our 45 degree finger down and count 1, 2 from the top,
Which is the square root of 2 over 2.
So the last thing we need to talk about is application of the unit circle. So when we apply the unit circle, we can find sine or cosine. Now when we find sine or cosine, we use this equation that we already talked about, which is sine squared theta plus cosine squared theta equals 1. And we learned about this over here when we were talking about the unit circle. In this next question, we're going to combine everything that we've learned so far. So it's going to include radians, the trigonometric ratios, and like all silly turtles crawl where sine and cosine are positive in quadrants.
Well, the question is, find cosine theta if sine theta is equal to negative 3/4 and theta is in between pi and 3 pi halves.
Okay, so for solving this equation, first we're going to put negative 3 over 4 squared plus cosine theta squared is equal to 1 because of this equation. So negative 3/4 squared is equal to 9/16. So when we switch this to the other side, it becomes 7/16 is equal to cosine theta squared. And then we have to take the square root of this to get rid of the 2. So cosine theta is equal to the square root of this, which is 7, the square root of 7 over 4. Now, since the square root of 7 over 4 is a square root, it can either be plus or minus. So we have to make sure to put plus or minus the square root of 7 over 4. But then we go back to what it says over here. It says pi, it's that theta is in between pi and 3 pi halves. Okay, so then when we bring out the unit circle, we can see that that is in between pi and 3 pi halves is in the third quadrant. And we know that sine is negative in the third quadrant. So the answer is negative 7 squared over 4. The next way to apply the unit circle is by finding angles with no trigonometric ratio. So for this, we're going to need these three equations, that sine pi minus theta is equal to sine theta, that cosine pi minus theta is equal to negative cosine theta, and that cosine 2 pi minus theta is equal to cosine theta. So the question is, find two angles on the unit circle that theta is greater than 0 but less than 2 pi, such that sine theta is equal to 3/4. So for this question, we need to figure out where sine is positive, because 3/4 is positive. And we know that sine is positive in the first and second quadrants. So we're going to need to find these two numbers right here. Since we're working with sine, we're going to use this equation. Now for the first thing we're going to do is we're going to use a calculator, because we need to figure out what sine theta is equal to 3/4. We can do this by dividing both sides by 3/4 and switching the theta to the other side. This is the inverse of sine. So sine, the inverse of it, is 3/4 is equal to theta. When we do this and put this in our calculator, that is equal to 0.848. So we know that one of the answers is 0.848, but that's only one of them, so we still need to figure out what the other one is. We do this by doing pi minus theta. Pi minus 0.848, we get 2.20. This is the other number. So we just found the two angles on this unit circle, this one and this one, 0.848 and 2.20. This was just one example with sine, but also you can see questions where there's cosine and negative cosine. So you need to be careful to watch out to use these specific equations for these questions. And that's all you need to know on radians and the unit circle.